Application of fine waste from iron ore beneficiation in reinforced concrete structures with basalt-plastic reinforcement. Iron ore beneficiation byproducts are artificial quartz-iron mineral mixtures that are fed into sludge ponds that form the so-called tailings ponds in the form of pulp. Tailings ponds occupy more and more territory every year and have a significant negative impact on the environment. At the same time, industrial waste from iron ore enrichment, the so-called tailings, is used as a fine aggregate to replace quartz and construction sand. Studies show that a 40% replacement of quartz sand with fine iron or dressing waste is optimal for the manufacture of concrete mixtures without any adverse effect on strength and durability properties. The paper considers the stress-strain state of beams in the second group of limit states made of concrete mixtures at 100% replacement of quartz sand with fine plant protection. Today, there are about 465 tailing dumps in Ukraine, which contain more than 6 billion tons of waste from various industries and, occupying large areas, over 7,600 hectares in Kryvyi Rih alone, have a significant negative impact on the environment. Flooding of adjacent territories, groundwater pollution, acting as a powerful source due to the drying of the upper part of the beaches. At the same time, according to the State Statistics Service of Ukraine, the volume of iron ore enrichment is not sustainable and increases every year, which leads to an even greater accumulation of industrial waste in tailings ponds. At the same time, industrial waste from iron ore beneficiation, the so-called tailings, is used as a secondary raw material of construction materials. In construction mortars, as fine aggregates in heavy and extra heavy concrete, for the construction of artificial foundations for roads, buildings, structures, backfills, in the production of concrete mixtures, it is plant protection products waste that is a full-fledged alternative to quartz sand, which is a versatile natural material used in various industries, glass, chemical, including for filtration, construction, concrete mixtures, plaster, etc., and metallurgy, molding sands for metal casting. According to open sources of construction sand production in the country, construction sand production, according to the State Statistics Service of Ukraine, almost doubled in 2021 compared to 2014 and amounted to 19.2 million tons. It should be noted that the extraction of construction sand from natural deposits in the floodplains of rivers and lakes leads to changes in the bottom landscape, which forms the soak where aquatic life lacks oxygen and water quality is significantly reduced. Soil erosion and salinization of aquifer. The experimental test program provided for the manufacture of 6 series of prototypes of concrete reinforced beams, 3 beams in each series. In accordance with the current requirements, the prototypes of all series were reinforced. The reinforcement of the specimens was intended to achieve the destruction of the beams of the control series due to the destruction of the stretched reinforcement. To allow comparison of test results, the percentage of reinforcement of beam sections of all series and the concrete class were assumed to be the same for specimens of all series. The BM series, made of concrete on quartz sand, was taken as the control series. For the reinforcement of the specimens, metal A400 and basalt-plastic BFRP reinforcement, provided by the manufacturer of composite reinforcement, Techno Basalt Invest LLC, Ukraine, was used. The mechanical characteristics of the reinforcement are shown in Table 2. For concreting, concrete of Class C25/30 was used at a concrete mixing plant. Beams of the BM, BB, and BMB series were made of concrete mixed with quartz sand as a fine aggregate, and beams of the BMD, BBD, and BMBD series were made of concrete with 100% replacement of quartz sand with small plant protection products waste. The latter is a fractionated quartz-iron mineral mixture with a density of 100 to 1,600 kg/m3. The composition of concrete mixtures is shown in Table 2. Based on the results of the experimental tests of the beams, Table 3 shows the information on the cracking forces of the beams. The results obtained, summarized in Table 3, indicate that the moment of cracking in the beams of the BBD and BMBD series occurred at a load that was 21.9% and 25.0% higher than that of the BB and BMB series, and in the BMD series beams minus 12.6% lower than that of the BM series. The moment of cracking for beams of the BB and BBD series occurred at more than half the load compared to the control series of BM. Fig. 3-5 shows the graphs of the load, crack opening width dependence separately for the series with the same reinforcement. The tendency to increase the width of the normal crack opening of beams under load made of concrete on fine plant protection products waste shows almost comparable results with the series of beams made of concrete on quartz sand. The overall performance of the beams of all series under dependence on the type of reinforcement used in the tensile zone. Beams reinforced with metal, BM, and BMD series, showed typical performance as for beams with traditional reinforcement. The first normal cracks appeared in the pure bending zone at a load of 0.3 to 0.4 of the destructive load. Further increase of the load led to the appearance of new normal cracks and thus, For the BM and BMD beam series, the width of the crack opening at 5.0 T and 7.0 T is the same, and in other cases the difference ranges from -20.0% to 23.5%. The beginning of reinforcement yield was recorded at a load of 0.9 of the destructive load, which caused the destruction of the beams with the compression of the concrete. The beams with basalt-plastic reinforcement of the BB and BBD series showed the largest values of the width of normal cracks, which is explained by the lower elastic modulus of the BFRP reinforcement itself. At a level of 0.1 to 0.2 of the destructive load, the first normal cracks appeared, and at the destructive load of 0.5 to 0.6 began to appear. A uniform location of cracks was noted, with a step of 100 to 150 mm, along the length of the beam. Figure 4 shows an almost linear dependence of the increase in the values of the width of normal cracks with increasing load, which is typical for beams with composite reinforcement due to the lack of yield properties of the latter. The crack opening widths of the BBD series values compared to the BB series beams at all stages of loading, and the difference ranged from -47.1% to -11.5%. The destruction of the beams occurred due to the crushing of the concrete of the compressed zone. No rupture or slippage of the BFRP reinforcement rod. The development of normal cracks in beams with hybrid, metal, and basalt-plastic reinforcement of the BMB and BMBD series can be divided into two stages, before and after the onset of metal reinforcement yielding. At a level of 0.2 to 0.3 of the destructive load, the first normal cracks began to appear. Up to a level of 0.4, the destructive load, the performance of the beams was similar to the BM and BMD series beams, which is explained by the predominant influence of metal reinforcement. After the appearance of reinforcement fluidity, basalt-plastic reinforcement begins to exert the main resistance to load. The behavior of the beams becomes similar to that of the BB and BBD series. The number and width of cracks in construction of the beams occurred due to the compression of the concrete of the compressed zone with the simultaneous complete or partial rupture of the BFRP reinforcement fiber. For further analysis of the obtained values of the widths of the normal crack opening of the experimental beams and the limit values according to current standards, Table 4 was compiled. The values of the width of the normal crack opening of the experimental beams given in Table 4 indicate that BMD series beams have the same value of normal crack opening width as the control BM series beams, 0 mm, and do not exceed the maximum permissible value of 0.3 mm. Beams of the BBD series reinforced with basalt-plastic reinforcement showed a larger value of the width of normal crack opening by 11.5% than the BB series, and exceeded the maximum permissible value by 93%. Beams with hybrid reinforcement of the BMBD series showed the width of normal crack opening than the BMD series, by 7.9%, and exceeded the maximum permissible width by 16.7%. It should be noted that at a level of 60% of the destructive load, beams with hybrid reinforcement of the BMBD series had a normal crack opening width less than the maximum. Summary. Studies of the use of small plant protection products waste in concrete mixtures for the manufacture of reinforced concrete structures show the following. There is no systematic control of annual volumes of plant protection products waste. Utilization. Plant protection products waste has a chemically unstable and heterogeneous particle size distribution at each individual enterprise and research. The time period between experimental studies and publication of regulatory documents can be more than 10 years, which slows down scientific and technological progress. Beams made of concrete on fine plant protection products waste showed comparable development of normal cracks with beams made of concrete on quartz sand under load. Beams of BM and BMD series showed the same value width, 0.9 mm, and beams of BMBD series, even less than the BMD series by 7.9%. At 70% of the destructive load, beams of BM and BMD series do not exceed the maximum permissible width of the normal crack opening, and beams of BMBD series do not exceed the maximum permissible width of 60%. There are no precautions regarding the use of concrete mixtures with 100% replacement of quartz sand with small waste of plant protection products for the structures working in bending with metal, basalt-plastic reinforcement and hybrid reinforcement with metal and basalt-plastic reinforcement at the same time. The crack opening widths for all cases of reinforcement have similar values, regardless of the concrete composition. The difference does not exceed 11%, which is within the calculation error for this